Overview of UML. So it consists of the major concept called conceptual model of the UML. So it consists of three elements: basic building blocks of the UML, rules of the UML, common mechanisms of the UML. So these are the three major elements plays a key role how to design the diagrams for software. So that comes to the first element, basic building blocks of the UML is furtherly divided into three sub elements called things, relationships, diagrams. So these are the pillars of the UML. Basic building blocks of the UML are the pillars of the UML. These will play a vital role in design of any kind of software application. So in that process, the first element called things is furtherly classified into majorly four types of things: structural things, behavioral things, grouping things, and notational things. So comes to the first one, structural things. These are static parts of the UML. Static parts, and also these are called as nouns of the UML. Nouns. So nothing but in any use case or the problem is given, in that use case we have different types of nouns. So we can represent the nouns using structural things. So in that, the first one is class. Briefly it describes collection of objects. Collection of objects. Second one is interface. So it is used to represent sharing the services collectively. Third one is collaboration, to represent interaction or to combine. The fourth one is use case. So here use case is used in two ways. One is to define the whole system and the requirement of the system. Then active class, to control the elements. So here we have class. It does not have any control, but active class is having some control. So that is the difference between class and active class. Active class is having the additional mechanism called control activity. The next one is component. It's a physical and replaceable part of the system. The next one is node. It's a runtime existing element. So we'll see in the next video in detail about all this. The next one is behavioral things. So these are the verbs of the UML. So whereas structural things are nouns of the UML, behavioral things are verbs of the UML. In English language, we have nouns, pronouns, verbs, adverbs, etc. etc. So in UML, structural things place like in nouns, behavioral things place like verbs. So we have two types of behavioral things: interaction and state machine. So we'll see in the coming video in detail about these interaction and state machines. The next thing is grouping thing, which is useful to combine the structural things and behavioral things. So as the name describes, group, combining. To do that, we have one grouping thing called package. The name itself is saying that packing the content, packing the content. The next one is annotational things. So these are useful to provide additional information. So in computer programming, we will provide the additional information which is useful for better understanding. For better understanding sake, UML also provides annotational things. So that is a note. To provide additional information, UML provides note called annotational things. So this is about things very briefly. In the next video, we'll see in detail about this. The next one is the second pillar of the building blocks of the UML is relationships. So here we have different things. To tie these things, to connect these things, we will use relationships. So nothing but to make or to design a meaningful diagram, we will use these relationships. These relationships. So the first one is association. So that is to connect two or more things, we'll use association relationship. So it is having different flavors, aggregation and composition. So we'll discuss in the next video in detail about these relationships. Next is dependency. So when one thing depends on another thing, we'll use dependency relationship. Generalization, when one thing acquires the properties from other things, we'll use generalization. And realization, when one realizes others, will use realization relationship. So not only these, so we have advanced relationships. So we'll see about these relationships in detail in the coming videos. The next one is diagrams. So the major purpose of the UML is designing a diagram for end user or client. So we are habited to use the softwares, but how it is developed or how it is engineered. So in software development, different people are involved. How they are developing the software. So I hope you know that what is software? A collection of programs. How many programs? N programs. So we are trying to executing some programs collectively. So program 1 is developed by one engineer, program 2 is developed by another engineer, program 3 is developed by another engineer, like that. Different people are or developers or software engineers are involved. So here the coordination and cooperation is required in development. It's not easy to connect one program with another program. So to understand the relationships that are existed between the programs, we need a media to understand the complete story of the software. For that purpose, we'll design the diagrams. So the first one is use case. Use case diagram. It is useful to design any system in two ways. One is if you want to design the complete system, nothing but what are the various features or services you are interested to provide. To model all the services that are provided by the software, you can use case diagram. And if you want to extend any one of the service or any one of the feature, because The service or feature may be a subsystem. So to model the individual subsystems, we can use use case diagram. Next one is class diagram. So this class diagram is useful to model the logical database. Logical database. Object diagram. It is useful to identify the various real world entities that are existed in the software application. The software application. Next one is interaction diagrams. So here we will identify various objects, how these objects are interacting with each other. To design that, we have two types of interaction diagrams. One is sequence and the other one is collaboration diagram. So in sequence diagram, when you want to model the communication between objects, how they are communicating, so that is dispatching the messages in time ordering, you can use sequence diagram. To model the structural organization of the objects, you can use collaboration diagram. So both are interaction diagrams. The next one is activity diagram. So here, if you take any software application, sometimes we are trying to executing the programs parallelly, two or three programs parallelly. So that is nothing but multitasking, multi-programming. Or one program may involves multi-threading. So in such process, if you want to model, you will use activity diagram. So here we will identify the various objects and their states, the various objects and their states, how the objects are responding for various inputs. So that we will model in activity diagram. Next comes to state chart diagram. So here state chart diagram is useful to model a particular object and its various states. Its various states. That is nothing but how one object is responding for various inputs during its lifetime. That we will model here. Whereas in activity diagram, will model multiple objects and their various states. In state chart diagram, single object and its various states. The next one is component diagram. So here software is existed in soft form, that is in terms of .exe files, executable files. So whenever you model for a software, we will implement multiple programs called N programs. To represent all these programs, we will use components, executable files. So we'll learn about this in detail in coming videos. Next one is deployment diagram. So every component requires some memory. Component itself does not have memory. So here executable source code files are represented like a component. Every component requires a deployment node to store all the computation that is performed in this executable file. So it is existed during runtime only. It is existed. Deployment node existed at runtime only. So these are created for the sake of component. So this is about basic building blocks of the UML very briefly. In coming videos, we'll discuss in detail about this. Next, rules of the UML. So here we cannot design as per our own interest. If we take the English language to frame a sentence, we will use subject, verb, object. In between the subject and object, we'll use depends on the situation. I mean tense. We'll use helping verbs, adverbs, and so on. So all these are used called vocabulary, English vocabulary, to frame a meaningful sentence. Similarly, to design a meaningful or semantic diagram, we have to follow rules of the UML. We have five rules. One is name. So nothing but in the diagram you have to name each thing, each relationship, each diagram. So in a diagram you may use structural things, behavioral things, grouping things, annotational things, all kinds of relationships. Then only we can call it as a diagram. So whatever you represent, you need to give a name. So this name is useful to identify uniquely what it is. Then integrity. So it tells us how far the elements that are designed in the diagram are integrating. Execution, scope, and visibility. So we'll talk about particularly scope and visibility. Scope, how long time that particular entity is exists, whether it is local scope or global scope, what is its lifetime, particularly when you model sequence diagram and activity diagram, state chart diagram. We'll talk about this scope. And comes to visibility, so here how it is visible to the external world, particularly in class diagrams. So in object oriented programming, we know that the class are accessed in many ways, like public, private, protected. So to represent that, we'll use this visibility. So these are the five rules are useful to design a meaningful diagram. Then the third element, common mechanisms of the UML. So these are the common things or ethics we have to follow while designing any software application. First one is specifications. Nothing but we have to define the software in terms of textual notations, specifications, using the globally accepted language called English. We have to specify, define in textual notations. Then adornments. So these textual notations are converted into pictorial notations. So that we will learn in coming videos using these basic building blocks of the UML and rules of the UML. Then common divisions. Generally, if any problem is given, we won't attack directly. We first will try to reduce the complexity of the problem. That is division of the problem. The problem is divided into sub problems into sub problems, and so on until finding the lower level elements called objects or grains, common divisions. And then extensible mechanisms. In this common divisions we will use these extensible mechanisms. So from which element the sub element is defined, sub element is defined. So when we go to the lower level, it's not easy to recognize. So we'll use these extensible mechanisms for easy recognition. Stereotypes, these are represented like this, called Gilman's. Constraints are represented like this. Tagged values are represented like this. So there is a difference between these two, constraints and tagged values. The representation is same. Tagged values always comes with the name. Constraints you can write anyway. So this is about conceptual model of the UML. This is the heart of the UML. If we have command on this, you can easily design any use case or any software application. So in this video we discussed very briefly. In coming videos we'll see in detail about all these things. Thank you.